Hello there and welcome to this Pandas challenge. This is day 11 of 30. My name is Valentine and I'll be your instructor. In this challenge or in this session, we are going to be going through a set of Pandas concepts, Pandas library concepts that will allow us to become better and better at using this library when it comes to data manipulation. So let's get started. The first thing that you need to do is to visit the description link for this particular video, and you can click on the practice resource link that will take you to the page that you're seeing on your screen. Once you do that, you need to click on the sample practice resource link, which should take you to this page. This is a notebook that we've curated that contains a few challenges that will allow you to practice more when it comes to Pandas. However, if you would want to practice extensively and also get other resources, including past resources within our library, then you can opt becoming an Afterwork member. It's just $5 a month. But that will give you just the tools that you need in order to become better at working with data-related tools. Right, so once you do that, once you get to this page, the next thing that you need to do is to go to File, then save a copy in Drive, and that should open a new copy in your new tab on the browser. And you can now use that. You can close this original one and use that for your work. I'll be using the practice notebook, which contains more challenges, and I'll open it in playground mode so that I am able to I don't want to save any changes. That's why I'll open it in playground mode, but you don't have to. If you want to save changes in your notebook, just work with it as it is. All right, so once we've gotten to save a copy, the next thing that we need to do is to now go to the prerequisite section and then get started by clicking on the first code cell, and we should be good to go. So the first thing that we're doing here, we're just importing the Pandas library as PD. And then once we do that, we should be able to have access to Pandas functions and functionalities. So yeah, so once that has happened, so once you've imported, it usually takes a bit of some time initially because we would be connecting our notebook also to Google servers, which is where our notebook is hosted. Our notebook is actually hosted on Google servers, so on Google Drive. We're using just computational resources provided by Google. All right, the next thing, we are going to get started with the first concept, transposing data frames. So transposing just entails being able to interchange rows and columns. If you have a data set that looks like what you're going to be seeing here, when we perform transpose, we would take the date columns and have them as rows, and then the rows column as the date. In some cases, this might be useful, especially maybe if you want to work with maybe specific, or you want to compare just data across the different columns, then we can be able to do that. For the purpose of just understanding how to perform this particular data manipulation technique of transposing, we are going to apply that technique on this data set. Don't mind so much about the end result, which is just the meaning of what will be outputted, but just I've learned that this is how you apply it. So we would reference our original data frame, which is DF, and we would apply the T attribute or property to that data frame, and essentially what we would have the rows now being the columns that you see here with the indexes representing the column names, then the columns is now the rows. All right, pause the video and then work on the challenge. The second method that we're going to learn today is to be able to work with the iLock method. We've gotten to have learned about this method in the past, but because we are going through challenges, the idea here is just to practice with the concepts that are available using the Pandas library, whether we are repeating them. The idea is just to get better and better over time. So we, in this case, are going to use the iLock method to select data. And when we work with the iLock method, we normally would use what are called integer positions. So for example, assuming that we have this data set and we would want to select the first 5 rows and the first 3 columns. So 5 rows are what you have here technically, but we also want to select the first three columns, 1, 2, 3, then we can use the iloc method by we would apply it to the data frame that we have, and then inside its square bracket, the first thing that we define is the integer positions for the rows. So we want from integer 0 to the one before integer 5, and from the column from integer 0 to the one before 3. So yeah, so that's what we do. So whatever that comes first in this case is treated as a row. Those are rows, actually, definition for rows and definition for columns on the right hand side. And generally that's it. Right, pause the video and then work on the challenge. So aside from using the iloc method, we can also use the loc method to be able to also select records from our data as well as columns. Now, with the loc method, we can use the column names, and we can also have conditions specified. So for example, when we are working with a data set that looks like what we have here, it contains just orders, about just generally customer orders, we can decide to select rows, say where the region is east, so the region on this side is east, and the customer, and we want to select rows where the region is east, but again we want only to have only specific columns presented. So we want customer name as well as the total price. So how do we do that? We use the loc method, and inside its bracket we specify as the first thing the condition that we want to apply when it comes to filtering. Then we specify the column names that we want to retrieve, and voila, this is what we have at the end. All right, pause the video and then work on the challenge. Right, in some cases we might want to create a histogram. So for example, if we wanted to determine how spread our data points are in a variable, or we wanted to visualize the distribution of that numerical variable, then that we have in mind, then we can use a histogram. With pandas, we can also create a histogram, aside from just using other Python libraries such as matplotlib. We can also do that with pandas. So here in this case, we are going to have this data set which we are loading. So here we have this data set which contains information. So for example, here we have it's like still the same information of orders, and then total price. So you can see we have total price. We apply, so assuming that we want to create a box plot for this particular variable, we can use this approach where we apply the plot function to the variable that we want to create a plot for, and then in that plot function we specify the parameter value for kind. So for kind we specify one histogram, then we define the number of bins. As would be when it comes to histograms, you need to define the number of bins. The bins will have a color which is sky blue, and the edges, that's the edge of those bins, will be black. And that's it. Just put a semicolon at the end. This is our histogram for that. Pause the video and then work on the challenge. All right, moving on, we can also create a bar plot, just as we did here with a histogram. We can decide to create a bar plot to just be able to visualize maybe some categories. So visualize any also categorical data. So assuming that we have this data set and we wanted to create maybe a not a histogram, but a bar plot for a categorical variable, such as maybe product category. We could also work with region or customer name. So this is how we would do it. So first of all, we would need to get the count of product categories. So if I print this out, let me print this out, summary. I should see that what I'm doing here is just I'm printing out the count of the values for the categorical variable, that's product category, and the respective count, how many times the value appears within the variable. That's what I'm printing here. And then once I do that, I am just using that output and applying a plot function and specifying, instead of specifying here hist, I will specify a bar, and then I specify the size of the plot. I want 10 dimensions by 6, the 10 dimensions horizontally, 6 vertically, then color of the of the bar and then the title. So yeah, let's run that. So this is our histogram, not a histogram, our bar chart. All right, pause the video and then work on the challenge. When we are working with missing values, we can perform backward filling. So this involves using the missing values. So for the missing values, we would use the next value that happens within that data set as a replacement for what would be missing. So for example, if we have this data set and we have maybe a missing value, such as in our case here, we have this missing value for total price NAN. That's for this record. We have missing value here. So for backward filling, we would use 600 to represent what is missing here. Forward filling we would use 100 to represent what is represented there. And in some cases, you could perform this technique depending on the use case, especially when it comes to time series data. But here again, we check for missing values. We see that total price, which is this column here, has missing values, this being one of them. To fill in those missing values using this method for backward filling, we use we first of all apply the fill NA function to the data frame itself, but we can apply it also to the specific column. Then inside that function, we specify the value of the method parameter, which is bfill. And essentially that's what happens. We replace the entire data frame, which is already replaced with now the outcome of backward filling, and we save it in DF field, and we can preview that, and we should see that here we had 600, so we should see for index 5 total price is 600. So let's run that. All right, so when you look at index 5, so we have 600. All right. Don't know why I'm getting double. Just rerun this. Okay, 600. And we can check for missing values as well, just to see that we have don't have any missing values anymore. Right, pause the video and then work on the challenge. Right, so in some cases, we can, let me just check on something. Okay, in some cases we can work with we might need to specify, we might need maybe to get a value within the data frame. So within one particular section. So for example, in the case that we have here, maybe we wanted to get just this value or this value, like, inside the cell. Sometimes we might want to just retrieve just one single value, but it may make sense, especially when you are building maybe, or you have a script that needs to select a certain part of your data frame. So it may help. It may help in knowing how to select such kind of data. So assuming that we have this data set, what we're going to do is to learn how to use what is called the IAT method. And what this particular method does, it's just like, the lock and iLock. But now this one allows us to specify clearly the row index as well as the column index for the value that we want. So for example, if we wanted to get the value at row 2, so row 2, that's the row, and the column, row 2, and the column would be column 4 with the index column 4. At index 4, so 0, 1, 2, 3, 4. So if you run this, you should be able to row 2 is actually the index 2, sorry. We should be able to get 800. So in our case, we would specify we want the index 2, and the value that you want to get would be would have this index 4. So that index would have, yes, it would have a position integer 4. So that's how we can be able to do that. And this method, which we use here, we can also use it to assign a new value to maybe this particular case. So we could decide, like the way we've done here, we just put on the right hand side an equal sign, maybe 500, 400 or 500. So we could remove what we have here and assign that maybe 1900. And essentially what would happen if I run this, I have put it at 1900. So if I refresh this, where is it? Okay, so I have done value. We are updating the cell at row index 2. Just trying to look at row index 2. This, don't worry about this. This is not applicable at the moment. Row index 2 and column index 4. So as 1900. I'm just trying to look at why it's not doing that. Let me check for this other one. This other one should also look okay. So if I preview it, let me check 8,000. So 5 and 6. So 5 and 6 should be 8,000. This actually works. This works for this particular case, but not sure why it's not working for this other case. Let me just comment this, run this again, then preview. Okay, it has worked. So 1900. So it's still the same approach where you specify again the positions for the row and the column index, for the rows and the column values, and then we just simply use some value on the right hand side. We replace that. That's it. Pause the video and then work on the challenge. In some cases, we might want to delete a column from a data frame. So this is a concept that we've learned in the past. There are two approaches. You could decide to select all the column names that do not have the column that you want, or you could decide to just drop it completely. So here we could decide to delete a column using the drop function, and we specify inside it the column that we don't want. If there are multiple of them, you just use square brackets. So you could have that's the first one. You could also have another, this is the first item. You also have another column, etc. Let me undo that, and we specify axis as one to just specify that we want to perform across the columns. And you display then the data frame. So in this particular case, we don't have the discount. Discount came after total price. So yeah, we don't have it there. Right, pause the video and then work on the challenge. A concept that we've gotten to have learned in the past was being able to create a new column. So we can, assuming that we have this data set, we can create a column using the assign method provided by Pandas. So we apply the assign method to the data frame, and then we define the new name of our column, and then we specify what that new column will comprise of. Is it a product of existing columns, which it is in our case here, and those values are stored in total sales, and voila. Right, pause the video and then work on the challenge. Lastly, we can use the shift method to just shift data in Pandas. So in some cases where we want maybe to, maybe calculate maybe percentage change in time, in a time series data set, then we can use this method. So assuming that we have this data set that we have here, this is just for providing not really so much of a better use case for the shift method, but it just helps us understand how we can be able to apply this technique. So assuming that we wanted to apply this method, we need to create a new column, and this will contain the shifted data. So total price shifted to be a new data. So and it will contain total price, which is the total price here, but now we would shift it one row below. So we apply that and then we preview what would be output. So here in our case, we have total price, the new price would be as shown. So the total price shifted would have the same values here, but now shifted one column below. Right, pause the video and then work on the challenge. Right, so that's it with regards to this challenge. I hope you are able to practice more. Some of these concepts are quite repetitive, and the idea is just to keep on practicing so that you don't forget and so that you put into practice what is normally used when it comes to Pandas for just basic data analysis tasks. Yeah, so I hope that you found this learning experience valuable. If you did, be sure to give it a thumbs up. It just tells us, and it also tells other people that this is a useful resource. And if you'd want to be informed when we post such future learning experiences, be sure to subscribe. All the best in your learning journey, and see you in the next challenge. That's on day 12 of 30. Bye-bye.